In our earlier lessons, we learned about how to build a class hierarchy. We were able to take one class, use it as a superclass, and have other classes that extend the superclass. So we had a bank account, and then we had a checking account that extends bank account. And we had a savings account that extends bank account. Well, that works well if a lot of what we need can be collected and put into a superclass, so it doesn't have to be implemented more than once. Now that's if we're writing all of the code ourselves and we decide upon this. But a common thing to do when designing a large system is that you build the superclass and you know what it is that subclasses have to do. You just haven't done it yet. And you know that maybe other programmers or even other companies or even your end users are going to be writing the code for certain methods that you know have to exist for something to work. Maybe you decide, I'm going to create a bank account, and I know everybody that extends me, whether that's a checking account or a savings account or a money market account or a line of credit account or anything, you know they all have to have a deposit and a withdrawal method. You just don't know what they're going to contain, but you know they have to have them. You can create either an abstract class or an interface that will force subclasses to have certain behaviors. That's the point of today's video. We'll learn two methods to do that. One is abstract classes and one is interfaces. So let's get started. An abstract class is a class for which the programmer never intends to instantiate objects. Instead, they're only used as a superclass in an inheritance hierarchy. So here's an example. In our earlier videos, we talked about a bank account class, but we never actually created any bank account objects. We created checking accounts and savings accounts. We might have had checking account, check 1 equals new checking account. Or savings account, savings 1 equals new savings account. But we never said bank account equals new bank account. We could have. We can instantiate any class that we've created so far. But there was no intent to ever have anybody create a bank account. Bank account was incomplete on its own. It just had the things that were in common for a checking account and a savings account. Well, we call that an abstract class. We can force a class to be abstract. That is, a class that you can use in a hierarchy, but you can never create objects of, with the abstract keyword. And here's how we do it. Public abstract class bank account. This keyword abstract is new. We used to just say public class, name of the class. If I include the keyword abstract, it means bank account is going to be a class, and I can put methods in here, and I can put variables in here just like I would any other time. But making it abstract means nobody can create an object of type bank account. Now, if you do that, you can just leave it like that and just make it so nobody creates a type or an object of type bank account. But if you have an abstract class, you normally are going to have at least one method in the class that's also declared abstract. So, for example, if we want to force anybody that extends bank account to create their own deposit account, we can do that by saying public abstract void deposit, give it the signature, pass in a double parameter called num, and then instead of putting the brace and the code for the deposit account, we just put a semicolon here. So what's different about this than what we've usually done? The keyword abstract and no code for the method, just a semicolon. We call this inserting the signature of the deposit class without having the body of the deposit method. So if I have an abstract class, I can choose to have an abstract method. This means that it's a contract with any class that extends it. If that code that we just looked at is in the abstract method bank account, and then I create a class checking account that extends bank account, checking account has to have a definition for all the abstract methods. I've got to have a method called deposit that has the exact same signature as the abstract method up in the bank account class. Or else I have to also make checking account an abstract class. And whoever extends checking account will have to implement deposit. So a class that isn't abstract is called concrete. We don't have a keyword for concrete. That's just what something is if you don't include abstract. And a class that isn't abstract is called concrete. You can only instantiate objects of concrete classes, not of abstract classes. Your programming assignment 9 is going to be all about creating concrete classes that extend an abstract class that I will have given you. And here's an example like you're going to use in programming assignment 9. You're going to begin to build an application that models a retail establishment. And we'll use this for assignment 9 and assignment 10. We're going to start out by setting up a simple payroll system. So here's the class hierarchy. There's an employee class, which is abstract. And then there are 4 concrete classes: salaried employee, hourly employee, commission employee, all extend employee. So anything that employee has as an abstract method, salaried employee has to implement. An hourly employee has to implement. It may choose to implement it differently. Commission employee has to implement it. It may choose to implement it differently. And then I've got in my class hierarchy something called base plus commission employee, and that extends commission employee. All right, let's turn our attention to something different than abstract classes, and that's interfaces. They have a lot in common. Like an abstract class, an interface is a contract in Java that ensures that specific methods will be implemented with specific signatures. But an interface isn't a full class like an abstract class is. I can't declare variables. I can't declare other methods that have a body. All I can put in it is signatures of methods that anybody that implements this interface has to include. So it's like a stripped down model of an abstract class that only has methods that anybody that wants to say they implement me as an interface has to include. So how do we do it? To create an interface in Eclipse, we do file new interface instead of file new class. And that will create for us this shell of code. Public interface instead of public class, and then whatever the name you provided. You put your code in between the braces. What goes in an interface? Only the signatures of mandatory methods. Only the signatures. No bodies, no variables declared. An interface is usually pretty short. It's just got the names of methods along with the parameters you would pass. So signatures of methods. So here's an example. Suppose I have an interface called payable. I want to be able to have some classes tell me that they are payable classes. If so, they have to include a method called getPaymentAmount that returns a double and has no parameters. So now how do I have somebody invoke the payable interface? Let's say I'm going to create a class called invoice. Public class invoice implements payable. Implements is a new keyword we haven't seen before. That says whatever word comes after implements is the name of an interface, and I agree to the contract. If I'm going to be something that's payable, anything that's payable has to have a method called getPaymentAmount. So somewhere in this class, I have to have public double getPaymentAmount that actually has a body. And I can do anything else in this class that I want. But this has to be in here somewhere. Now, I can also have a class like salaried employee that extends employee. So it's part of a class hierarchy. And in addition to extends employee, it can implement payable. That means it's got to fulfill the contract of anything that employee said was an abstract method, plus anything that payable says I have to do. So since it implements payable, it has to have a public double get payment amount. This example on this page is taken from your programming assignment 10. Here's some fun facts about interfaces. A class can implement more than one interface. Suppose you're building a fantasy game, a role-playing game, and you decide that you want to create public class dragon. And you want dragon to be able to do everything that magical things can do and everything that movable things can do. So when you create the class dragon, it implements magical and movable. Now, magical may say that it's got to have a method to cast a spell and a method to recharge the spells and a method to determine what the damage is from spells. Movable may have to include things like how far you move in a particular turn, how your movement is affected if you're tired, and so on. A class can also extend another class as well as implement one or more interfaces. So suppose your system has a class called player. Well, maybe you're going to now create a class called wizard that extends player. Does everything a player does, and maybe you'll override a couple of methods or add something new. But it also implements both movable and magical. So, unfortunately, we won't be creating wizards, dragons, magical, and movable in this course, but you will be using interfaces and abstract classes and methods. Happy programming.